All right, so I think this is recording. We have three equations here that are quadratic equations. We want to solve them. Although I didn't cut and paste the directions, it says to use the quadratic formula. So um, let's write each of these in standard form. So in number 13, we have 1x squared plus 1x. Subtract 12 from each side. Minus 12 is equal to 0. Let's identify A, B, and C. And let's go ahead and find the discriminant first. That'll tell us what to expect about the solutions. B squared, well, 1 times 1 is 1. And we've got minus 4 times 1 times a negative 12. And the negative times negative is positive. 4 times 12 is 48, plus 1 is 49. 49 is a perfect square. When you take the square root of that, you're going to get 7. So that we're expecting two rational numbers as solutions. So the quadratic formula in the denominator says 2a. Well, 2 times a is 2 times 1, which is just 2. And in the numerator, it has two terms. The first term is the opposite of b. The opposite of positive 1 is negative 1. And then it's the square root of the discriminant. Well, we just found the discriminant, and the square root of 49 is 7. So this gives us two solutions. Negative 1 minus 7 is a negative 8, and half of negative 8 is negative 4. And negative 1 plus 7 is 6, and half of 6 is 3. So here's our two rational values. And we know, too, also that had the directions said that to factor this, we could have easily factored this. But you don't want to do that as your solution. You have to follow the directions. If the directions say solve by the quadratic formula. Now, we could use another method to check our answers. Kind of depends on if it's a test or quiz, if you have time to do that. All right, so let's look at this second one. It's not in standard form. Let's get this in standard form. Let's subtract 24x from each side. Let's subtract 9 from each side. Let's identify A, B, and C. Let's find the discriminant. The discriminant is b squared minus 4 times a times c. 24 squared. Well, 25 squared is 625, but I don't know what negative 24 squared is. 576 is what my calculator tells me. Seems reasonable. All right, so what do we have here? I key this in the calculator. I'm getting 828. Now, I don't believe that that's a perfect square. Let's take the square root of that and see. No, it's not a perfect square. So I'm expecting in my final answer to have irrational numbers, to have radicals. And the directions also said it wanted exact values, so I can't jump to a calculator and give a decimal number as an answer. I'm going to have to give my answer in radical form, and which also means reducing it. So let's go to the quadratic formula. The denominator is 2 times a, 2 times 7 is 14. In the numerator, we have plus or minus. In the first term, it's the opposite of b. The opposite of negative 24 is a positive 24. And then it's plus or minus the square root of the discriminant. And we found that discriminant to be 828. So we take 828, play around with it on the calculator. I thought it might be divisible by 16, but it's not. So 828 is equal to 4 times 207. Now, I think 207 is probably a prime number. I don't think we can find any factors of it. No, I take that back. 207 would be divisible by 3, wouldn't it? Yes. So this guy would be 3 times 69, and this would be 3 times 23. So 4 times 9, this 828 was divisible by 36, and I didn't notice that. Yeah. All right, so this 828 is 36 times 23. And I know when I take the square root of 828 that I can take the square root of these numbers individually. So let's return over here. When we take the square root of 36, we get 6. But we can't do anything with that square root of 23. Now, we see that these, in the numerator, these two terms are even numbers that we can factor out of 2. 2 times 12 is 24. 2 times 3 is 6. And in number 14 here, I can write it as 2 times 7. So since this is multiplication right here, these common factors cancel. They divide to 1. Be careful. You know, every year I see students that come in and they'll pick, you know, the first term and divide it by 14, or but they don't do anything to the second term, and that's incorrect. See, you're dividing this whole binomial by 14, which means both terms. So our final answer here, 12 plus or minus 3 radical 23 over 7, if I haven't made any type of silly error in the above work. Oh, we've got one more to do. Let's shrink this up, or at least try to. Well, I really wrote big that time. All right, so let's get that out of our way. Let's come down here. This is not in standard form. I like to have my leading coefficient be positive. So I'm going to move these terms to the right-hand side. So I'm going to add x squared to each side. I'm going to subtract 1x from each side. And I'm going to leave the 5 where it is. So now I can easily identify A, B, and C. I can come in and calculate my discriminant because I've got to do it anyway. It's part of the quadratic formula. B squared, negative 1 times itself is positive 1. And so we have 1 minus 20, which is a negative 19. And there's a little bit of the advantage of finding this first, because now we can conclude that there's no real solution. No real solution is a better answer than no solution. This equation does have solution. It's just that it's within the set of complex numbers. We'd have to, and we do this in skill packet number 6, we define the square root of negative 1 to be the imaginary unit I, and then we can come in and find the solutions to this quadratic equation, and to really to any polynomial. We'll have solutions if you consider the complex numbers. All right, so I hope that helps. Ask questions if you need to, and I will talk to you later. Bye.